Hello everyone and welcome to Brain Blitz Audios. Today, in this episode of Keam Prep, we're going to be looking at some previous year questions of the Keam examination. We're going to be looking at questions from various subjects from the Keam examination and find out how to solve them effectively. So let's start off with our first question. This one is from physics. Which one of the following characteristics is not associated with a paramagnetic material? It's weakly magnetized in the direction of the magnetizing field in which it is placed. Its magnetic permeability is greater than 1. Its magnetic susceptibility is positive. That increases with rise in temperature. Its individual atom, molecule, or ion has a net non-zero magnetic moment of its own. So, how do we solve this question? Let's look at each of the statements. A paramagnetic material is indeed a material that is weakly magnetized in the direction of the magnetizing field. So statement A is true, which means that that option is incorrect. Now, since it's weakly magnetized in the direction of the magnetic field, its permeability is greater than 1 and its susceptibility is positive. So both statements are true, which means that both options are incorrect. Its individual atom, molecule, or ion has a net non-zero magnetic moment of its own. That is true because that's the reason why it can be magnetized, although weakly, and that's also the reason why its permeability and susceptibility are positive and greater than 1. So therefore, the statement is true, which means the option is incorrect. The right answer is option D. Magnetic susceptibility increases with rise in temperature. In fact, the susceptibility of paramagnetic materials actually decreases with rise in temperature because magnetic susceptibility of a paramagnetic material is inversely proportional to temperature. So, option D turns out to be the right option in this scenario. Now let's look at the next question. Which one of the following molecules is formed by sp3d hybridization? Is it BRF5, PF5, SF6, CONH363+, PTCl4. Now, we need to look at the hybridization of all these materials, all these molecules. First off, SF6, it needs to have 6 electron shares. So that means its hybridization would be sp3d2. For options D and E, the hybridization that is found in nature is usually D2sp3 and DsP2 respectively. So here you got 6, here you got 4, so therefore the differentiation. So as you can see, they start with D, so therefore sp3d hybridization is not found in options D and E. Now amongst option A and B, the two candidates with the most likely case for sp3d hybridization, which of these would be correct? Now, if you look at A, you can see that it's a union between bromine and 5 fluorine ions. So therefore, that means fluoride ions. So therefore, that means the hybridization would be a bit skewed. And in fact, if you look at it, it's actually sp3d2 hybridization because the electrons in bromine shift around a bit because the D orbital also gets involved. So therefore, option A is incorrect. That means the right answer is option B, PF5. Potassium pentafluoride has sp3d hybridization. It's got 5 electron shares, so therefore that is distributed across 1s, 3p, and 1d orbital. Now let's look at the final question for today. The order and degree of the differential equation d square y by dx square plus under root of x square plus dy by dx the whole raised to 3 by 2 is equal to 0 are respectively 2, 4, 2, 3, 2, 2, 3, 4, 4, 3. So how do we solve this question? Well, let's look at order and degree and find out what they are. The order is basically classified as the highest order derivative in a differential equation. In this particular scenario, that is 2. Since we have a d squared y by dx, that's a second order derivative, which means that the order would be 2. Now, degree is basically the power of the highest order derivative. Now, basically you usually look at the highest order derivative and find out what is its power. So in this particular equation, it looks at first glance as if the power is 1. So the degree would be 1, right? However, in our options, you can see that there is no degree with 1 in it, which means that there is more to this equation than just what's seen. So what we can glean from our deductions so far is that options D and E are incorrect, because in both of those options, the order is not 2. They're saying that you've got third order and fourth order derivatives, which is not correct. So we have 3 options at stake. We need to find out which of these is correct, and for that, we need to work on the equation we have. So as you can see, in this particular equation, some of the derivatives are actually worked over by roots and exponents. So what we have to do is we have to remove them in order to get the clear picture. So firstly, in order to remove the root, what we do is we square both sides. So what we're going to get is, we'll consider d squared y by dx squared as one term and the entire root as another term. So this is akin to a plus b the whole square, which is equal to a squared plus 2ab plus b squared. So when you square both sides, what we get is d squared y by dx squared the whole squared plus this entire term with its root removed. So that will be x squared plus dy by dx the whole raised to 3 by 2. And next is 2ab. So that will be 2 times d squared y by dx squared multiplied with x squared. Actually over here, since this is under root, so we actually have to do x squared plus dy by dx the whole raised to 3 by 2 whole raised to 1 by 2. Now, as you can see, we've still got work to do here, because we've got 3 terms now. Now, as you can see in the second term, you've got 3 by 2, again with so let's instead of going on further simplifying it further, let's start working on this particular equation. So what we're getting here actually, you know what, let's go the other way. So what we're going to do here is we've got 3 terms, and you can see that 3 by 2 of the first order derivative. The first order derivative is under the exponent 3 by 2. So we'll square both sides again. So what we're getting this time is a plus b plus c the whole squared, which will be a squared plus b squared plus c squared plus 2 times ab plus bc plus ca. Now we don't need to do the whole thing in order to get our answer. So when you square both sides, the right side is still 0, by the way. 0 squared within 0 whose exponent is any number would still be 0. So when you square both sides again, we're getting d squared y by dx squared the whole raised to 4 plus this particular part is getting squared, so what we get is x raised to 4 plus dy by dx the whole cube plus 2 times plus 2 times x squared times dy by dx the whole raised to 3 by 2. Plus, you can work with c and you can work with the remaining terms, but that really does not matter. We know that our order our equation is a second order derivative, and after removing the square root twice, we found out that the degree of this particular differential equation is actually 4. So therefore options B and C are also incorrect because the degree is different from what we got. The order of the particular equation is 2, since it's a second order derivative, and the degree of this equation, after squaring both sides twice, is actually 4. So therefore, option A turns out to be the right answer. So that concludes this episode of Keam Prep. We hope you found this episode interesting. For more of our useful and interesting videos, please subscribe to our channel, Brain Blitz Audios. You can also hit the bell icon to get the latest updates. So until the next webisode, take care, stay safe, bye-bye for now.